Okay, so EOC, like, so we have 3 of them. You still need a common denominator. And you guys watched your video today, and if you have a way of doing this already, different than mine, that's fine. Again, as always, I just need you to get it correct. If you have questions, whatever, I do what works best for me. So you want to check the bottom and make sure everything's factored first. This does have a GCF of X, so you definitely want to factor it. Now, what I've done in the past, every time you add or subtract a fraction, you have to have a common denominator. And you would like it to be the least common multiple common denominator. But what I've done is when I look across, instead of trying to overthink, and sometimes it can get to be sort of taxing on your brain if it's tons of them, like if there happens to be 3 binomials or 3 numbers that could work. I take whatever's in the bottom and I write it across the top. X plus 5, x plus 5. This will also set you up for the last, we have word problems coming in like 2 days. Same process of solving. So then whatever's in the denominator that's now up here in the numerator, I cross out. So I have an x left and an x left. I cross out my x. I have 9 plus x and x plus 5 left. X, all these guys are gone. So all I have left is 25 at the top. Now, big call out because you have a minus, which means really that's going to become a plus, and that 25 is going to become negative. So I'm going to multiply x times x for that first one, and then 9 plus x times x plus 5. And I may be overwriting for your brain right now, but again, I'm always just trying to show you where things come from. And then all I have is 25 left on the top. Your common at the bottom is going to be that x plus 5. And as we talked about in multiplication, this might be in the form of where it's already multiplied out. So not factored form, depending. You could go either way. And both are correct. It's just a choice of formatting. So x times x, we're going to have x squared. Plus, we want to multiply these guys together. So 9x plus 45 plus x squared. 9 times 5 is 45. X times x is x squared. And then x times 5, 5x. And then I have minus 25. Now you're going to clean all this up. So like terms. So I have x squared. So 2x squared. And then I want it in standard form. So x squared first. Then I have x, 9x, and 5x, which is going to give me 14x. And then 45 and negative 25 are constants. So that's going to be plus 20. This, you do want to check. The only downside to doing it in this way is it may not be your least common multiple always. I would always double check, especially the top, once you combine all your like terms. So that 2x squared plus 14x plus 20. Is there a GCF, and could it possibly be? In this case, it'd be great if it was a variable because we could cross things out. It's not a variable because there's a constant back here with no variable attached, but we could pull out a 2. Which in this case doesn't help anything cross out, so it doesn't make a difference. But you do want to check it. And that would be your 2x. So we're just going to stick with our condensed version for our final answer over x squared plus 5x. I'll give you a minute just in case you're writing. If you have any question, hit me in the chat box, or obviously, you can talk to me. So in case you're writing these down, here's our second one for EOC, like so multiple expressions. We're adding 3 expressions at this point, and I'll give you a minute to write that down. And then we'll go over that one. All right, so first and foremost, we want to factor out anything in the bottom or top that could be factored. X squared plus 5 looks like it could be factored, but it cannot because there's not an x in common. It's not subtraction. That you can't take the square root of 5, so it's as good as it gets. 2x is as good as it gets. X minus 5 also as good as it gets. X plus 4 is great. X minus 4, x squared minus 16. So we should be able to factor that one. And that's at differences of squares. So it's going to be x plus 4, x minus 4. Because remember, there's always a positive and a negative every time you take the square root of anything. So again, my way, minimize thinking, I'm going to write x plus 4, x minus 4, because I see plus 4, minus 4, and then it repeats itself. X plus 4, x minus 4, x plus 4, x minus 4. We're going to cross out from top to bottom. So numerator, we're ignoring the middle right now, which is the numerator from the problem. We're ignoring it. So we're going to cross out what matches, and then we're left with these guys. Cross out, left with, and these guys all cross out, and this is what we're left with. Now remember, it appears that this is going to be our best. So it could be x plus 4, x minus 4, or written as x squared minus 16. Both are allowed. Now across the top, we're going to multiply together what's left over. So x minus 4 times x squared plus 5. Then we're going to add that to 2x times x plus 4. Then we're going to add that to x minus 5. Is everybody okay with where all those things just came from that I just wrote down? Or is this close enough to what you were doing before right now? Cool, perfect. So you can do this again by FOIL or box method. So x times x squared is going to be x cubed. X times 5 is 5x. Negative 4x squared, negative 20. Then I'm going to just stack my like terms, trying to clean up for myself as I go. So 2x times x is going to be 2x squared. So I'm going to put it with that negative 4x squared. And 2x times 4 is going to be 8x, which goes with, and that's a positive, 2x squared. Positive 8x goes with that 5x. And then we have x minus 5. So x goes with our x's, and then minus 5 here. And hopefully that didn't confuse you too much. You can write it straight out all the way across. I just like kind of the grouping. So again, your highest first, standard form. So we took care of that one. Then x squared would be next. So negative 4x squared plus 2. You owe me 4, I pay you 2. You owe me 2x squared. Then we have our constant, or x to the first power. And that's 5 plus 8 plus 1, because there's that imaginary 1. So I end up with 14x. And then negative 20 and negative 5. And I'm just crossing them off so I know that I haven't missed anybody. Negative 20 and negative 5 means negative 25. Now, in this case, this is a cubic function. It's going to cross the x-axis 3 times unless there's imaginary. And I'm just adding that to our conversation to remember from polynomials. There's not an x at the end, so likely to not be factorable. So there's not going to be a GCF to cross out. So we're going to leave it just as is. And since it's in this neat, nice form, more than likely you can expect the bottom to be in the simplified or multiplied out form as well. And I have one more. Give me a second. All right, and then of course we have to have one with a trinomial in it because we got to make sure we're good at factoring and all the things. So I'll give you a second to get that one down if you want to take notes on this one. So hopefully you're seeing that it's really not terrible. It just looks wild because you're not used to doing a ton of them, like I'd said in the beginning. So first thing first, check where you can factor things out. The trinomial is a good start for sure, always. This case, a is 1, so that's awesome. So we know that this is going to be an x and an x. We're looking for multiplies to give us 2 that will add or subtract to give us 3. The fun part about 2 is it's always just 2 and 1. That's it. And now it's deciding which one's positive, which one's negative. If B is positive, the largest one has to be positive. So I know I have $2, but I want to have 3, so that means I need to add $1 more. I would also at this point maybe look at this and turn it into a plus and add that negative there so you don't forget it along the way. So fix all the things of that nature before you start crossing things out and making a hot mess of your problem or solving at that rate. So looking at the bottom, I have x plus 2, common, good, x plus 2, and then x plus 1. So I'm going to write x plus 2, x plus 1, x plus 2, x plus 1. Then I'm going to cross out what I can from the top and the bottom. So both of these go away. I'm left with 5x minus 1. X plus 2 goes away. I'm left with negative 2x and x plus 1. X plus 2 goes away again, and then I'm left with 4 and x plus 1. So for our first set, I end up with 5x minus 1. And again, just to call out, the base is going to be x plus 2, or denominator x plus 1, which could also be written as x squared plus 3x plus 2. Negative 2x and x plus 1. So we're going to multiply those together, and then we're going to multiply 4 times x plus 1 for each of those terms. And since we went ahead and put the negative there, this is all just, we're going to combine like terms when we're done here. So 5x minus 1 is good as it is. So negative 2x squared, negative 2x. We've now taken care of that and simplified it. 4 times x is 4x. 4 times 1, 4. So what we're cleaning up is 5x minus 1 minus 2x squared minus 2x plus 4x plus 4. And I put the plus there because that's positive, and that minus is because that's negative. And again, now you're going to combine your like terms. X squared is the largest, so it's going to go first. That negative 2x squared. So we can cross him out because we took care of him. Now we're going to look at our x's. So we have minus 2 plus 4 plus 5. So that's 9 minus 2, which is going to be 7x. And then last but not least, you have your constants of that negative 1, positive 4, so it's going to be negative 3. Again, I would check for a GCF just in the case. You might be able to cross something out, like if there was a whole number hanging out at the bottom or something of that nature. But in this case, there's not one, so our final answer is going to be negative 2x squared plus 7x minus 3, x squared plus 3x plus 2 on the bottom. Now, you shouldn't have a conversation about restrictions or excluded values in this case, but if they do, they are discussing what are the excluded values from the solution at this point. So after you've done this, because you're going to force every single factor for like a term that's in the denominator throughout all 3 of them. So in that case, then it may be better to remember this somewhere on your piece of paper, and then you're just going to set x plus 2 equals 0, x plus 1 equals 0, and solve for each. So the excluded values would be that negative 2 and negative 1 if you solve those. I very rarely have seen them have that conversation in this format. It's usually typically more in the division, because they want to see if you remember to do it twice. And then simplification, just because that's really it. Can you factor? Do you know what excluded values are?